So I've changed my title a little bit. I don't think it really matters what my title is. But I was thinking because I was wondering how exactly did I get here um, to be invited to give this talk. Uh, because you probably don't know this, but like just 50 years ago, I actually found a photo of me 50 years ago. Um, the 2007 Martijn was a scientist, and I didn't actually believe in open source. And I don't know if I said this like literally like this, but certainly my belief was that scientists who do science not maintain software. And now, 15 years later, the 2022 Martijn is considered by some at least a leader in open source software, or else I wouldn't have been invited here. And I spent about a quarter of my time to actually maintain software. So something happened in those 50 years, and what is it? Well, I think a important part about is about what happened is what is unique about Odyssey. And so recently we've been looking at other open source communities, and some of you have seen maybe also the video about Apache, which I highly recommend. It's on the teams to take a look at that. Their slogan is community over code, and I I don't reject that at all. I think that's a very good slogan to have. Uh, what I like about what Odyssey has been about in the past, at least, and maybe that's changing now, and probably that's good. But in the past, our slogan's been science. And bonus points for whoever recognizes the comic that I'm using a photo of here. And so, what is science? I think is an important question. I want people to think about. And so I'm showing you here one of my favorite books that I've ever read, Zen and the Art of Motorcycle Maintenance, who has a lot to say about science. And so I think the quote that is most captures to me what science is this one. The real purpose of the scientific method is to make sure nature hasn't misled you into thinking you know something you don't actually know. And that's it. I think that's the core of science. So you think you know lots of things, but what assumptions am I making when I think that this is the truth? And if I'm making those assumptions, well, can I test those assumptions? Or the way that science often works is has somebody else already tested them, and I can just reference what they did. Um, and so I think this really is the core of science. And so, like the last couple of years, we had lots of people with COVID and COVID vaccines mistrust science, and to me, that fundamentally doesn't make sense because really, it is just like thinking really hard. Do we actually know what we think we know? And so science, I think, is very important to Odyssey because that's actually how Odyssey started. And Odyssey, as many of you know, started with OMOP, the Observational Medical Outcomes Partnership, which was a project. And the project was all about this single question, answering this single question, which I like to formulate as, can we be misled if we apply current best practice research methods to observational data? So everybody was generating evidence from observational data, publishing it, and I think it was primarily Patrick who started wondering like is that really a good way to do it, and could that possibly mislead us? Could we trust the answers? And so to answer that question, a scientific experiment was set up to basically test the assumptions behind this question. And at a high level, this experiment was very like simple and elegant in its setup. You just implement all the methods that are being used. You define a gold standard of exposure outcomes pairs where you know that what the truth is. You run it those methods on the data and see whether you actually can reproduce the gold standard. What made what made this experiment actually very crazy was just the scale at which it was applied. But the basic principle is very straightforward. And by the way, a side product of this experiment was what is now the OMOP Common Data Model, which is the center of all of Odyssey. And so the answer that came out of this experiment was a resounding yes. Yes, you can actually be quite strongly misled by just applying these methods and believing that they produce the right answer. The experiment showed that quite often what we know is the truth is very far from what the method produces as an output. And this is actually very important to know because many papers were published and are still being published using these methods every day. And this experiment is telling us that there's something, yeah, we should be very concerned about that. What I think is also very important about this experiment is that it didn't just show that there was a problem, but it also showed some light on the horizon. Because yes, it showed that the current methods are mostly problematic, but it also shows that if you apply science and scientific principles to these methods, you can actually make them better, and you can actually make it so that you can generate reliable evidence using observational data. And I think that's really where OHDSI then took over from OMOP. So how can we now make this dream a reality? And open source software is really at the core of realizing this dream. So on the one hand, we still have the methods research that was started in OMOP, where we use empirical science to evaluate and improve the methods that we use to generate evidence from observational data. But then we need to actually implement those methods. And so, for example, in Hades and in Atlas, we are implementing these best practices as we've learned through the methods research. And we then even go further in OHDSI is that we then use our own tools to do what I'll just call clinical research, which means we apply these methods to actually generate evidence to improve healthcare and hopefully eventually make the world a better place, I would think. And so without the open source software in the middle, none of this actually would be possible. I also think it's important to point out that it's important that this software isn't just implemented, but that it's implemented as open source. Because a key aspect of science is that it's transparent, reproducible, and because it's reproducible, you can actually then critically evaluate it again. So making it open source is, I would say, a hard requirement for doing observational research. And so, from my perspective, so I view our open source software mostly from this science lens, and in my view, and of course Adam already showed we're successful in other ways as well, but from a scientific perspective, I think we've been very successful in what we've achieved in the past couple of years. So just counting, I counted 21 methods research papers that use Hades to generate evidence on how best to use observational data. And that's just the ones that I'm aware of. There will be more. I also counted, and a good example of that, or one of my favorites, is actually one I led, is the one in the bottom left, where we used the Hades tools to evaluate all different sorts of methods against a benchmark that we established. We have at least 25 clinical research papers using Hades, and that's just the one that I could count, and I'm aware that there are many more of this. It's probably 50 or 100. So this is actually actual evidence generated using the Hades tools that contributes to improving healthcare. And of course, a good example there is the paper in the bottom right, which is our Lancet paper, where we looked at the various antihypertensive and compared them in terms of their effectiveness and their safety. Of course, also among these clinical research papers is our work on COVID and COVID vaccines. And as we've actually seen is that work has directly impacted decisions by the EMA. And we think FDA, although we don't know for sure. So I think we have our science has had, and through our software has had a major impact already, I think. But I think that's good, but I think the best is actually still ahead. And so I do want to point out that recently the EMA has identified the Erasmus Medical Center as the coordinating center for the Data Analysis and Real World Interrogation Network, or the Darwin Network. And I think this is a very exciting development, not only as a recognition. Erasmus MC, of course, has been a core partner of OHDSI for quite a while, but also because the idea at least is that Darwin will run on Odyssey's principles and our software, generating evidence for the EU and hopefully also for the rest of the world. So I think this is a huge opportunity for us to have even more impact to use it through our open source software. I do have to give a bit of a warning here that if we want to actually achieve this and make this a reality, we have to be very aware of what Darwin's needs are, and that we ensure that our tools meet those needs. So you'll probably see me in the next couple of years actually really pushing hard on, and that we make sure that we're aligned on this specific issue. All right, so how did we achieve all this success? I don't have a good answer, but I'll tell you just how the Hades community, at least the part that I'm most familiar with, evolved over time. I think it started somewhere in 2014 where we developed the first package, the first version of Achilles, the Achilles R package, and to make that work, we needed SQL render and database connector. In the following years, we started developing more analytics R packages such as Cyclops, core method, base level prediction. And then in 2018, I thought it was time to establish the methods library. So we were having more and more R packages, but I wanted to basically single out a select set of those that were verified through empirical validation, and where we started to focus on the stability and validity of these packages. So these would really be the packages that we would recommend people to use when they generate evidence from observational data. In 2020, we realized that methods library, that term no longer really covered everything that was in what is now Hades, so we just rebranded it as Hades. And since then, we've been growing the community quite a lot. One thing to point out is that at the beginning, so I remember Patrick and me working in my home, writing the code for the first Achilles version, and then later on it was primarily me, Mark, and Jenna working on these initial R packages. I think it's important to point out that those people, they're all scientists, and I think one of the things that we've been very grateful for, and I think contributed to the success, is that we also started adding like people that would primarily identify themselves as developers, and so having a good mix of developers and scientists, I think was crucial to the growth and success of Hades. What we also try to do is define standard and some initial standards and interfaces. Of course, a common data model was already a standard from the start, but that's been a very important standard. All our tools run against the common data model. We've also defined a standard release process and versioning that is used throughout all of Hades. We have things like code style guidelines and developer guidelines that were set up, so that even though the community is growing, we're still hopefully all aligned in our work. We have open meetings and open discussions. So if anybody wants to join our meetings, the third Thursday of the month is always the day for the Hades meeting at noon Eastern time. Just last year, we had our unit testathon, which I thought was a great success. So this was really the first time that in a Hades context, we did something like a hackathon. Lots of people joined, lots of new people actually joined. And so I very much enjoyed this experience, and we'll be continuing this in the future. We're working on, but we'll let you know on this with more details. At the Odyssey Symposium, we'll have another hackathon in the days after the actual symposium, so on the Saturday and the Sunday. So I'm very happy to say that we now actually have 12 unique Hades maintainers. So Adam already showed you this dashboards, which shows you for every package who the maintainer is, and so you see that some maintainers maintain one package, and some maintain more than one package. But I think these are really key individuals to have in an open source community, because these people really ensure the continuity of a package. And so I therefore just want to explicitly call them out. So Adam Black, Anthony Senna, Chris Knoll, Jamie Gilbert, Jenna Reps, Frank DeFalco, Gautam Rao, Lee Evans, Mark Suchard, Martin Lavely, and Peter Rijnbeek. And so, yeah, big shout out to these people for putting in their time and enabling Hades to persist. I want to make a short side jump to the rabbits also. A special call out to Maxim Monet from the Hive and his work on the rabbits. So I started initially to work on the three rabbits, White Rabbit, Rabbit, and Adu Sagi. But Maxime was able to take over from me and has done a tremendous job in refactoring the code and making sure that it's robust and usable. I think even specifically for that, he got the 2021 Titan Award. So thank you, Maxime. All right, so that's where we are right now. Where do we go from here? Well, I don't have a spectacular answer. I think we need to grow the community, meaning we need more users, more contributors, more developers, more maintainers, and even more leaders in our community, because we have so much more work to do. So I don't think that's a very surprising goal to have. I do want to emphasize that while we do that, we should keep the science at the core of our software. So how do we grow the community? So I wasn't really expecting to see this plot earlier in the day, but I liked very much this model or this idea that we have different levels through which people progress. So we start at the bottom where people are just never used our tools before, and then hopefully we can get them to at least try to use our tools so they become users, and so we will have hopefully many users. A small fraction of that will then hopefully progress to become contributors, or maybe create issues or even small pull requests. And then once they do that enough, a smaller fraction even of that will become hopefully developers. An even smaller fraction will become maintainers. And so really you need a very wide base to have anybody left at the top. And so how do we grow the community? Well, the idea is to provide on-ramps, so to make it easier for people to enter at the various levels. And all the way at the bottom is just making people users. And one of the key metrics there that was proposed a while back is that you somebody has to be able to do something meaningful with your software in, I think it was 10 minutes, and from scratch. And for those of you who've tried to install Hades, you know that you're not gonna do that in 10 minutes, let alone actually do something meaningful with it in that time. So things that we need to focus on is just making things easier to install. So maybe we should look at Docker or something, or something else, and also provide some easy examples for people to just get started with our software. Another important point, I think, and one thing that we're also actively working on is our users aren't necessarily, even though we're in Hades writing our packages, our users aren't necessarily our users. They are usually just people that want to do analyses on observational data. So we should be better at allowing users to run analysis without any knowledge of our code. So like I said, that's something that we're working on. But also provide for the next level, for people that want to learn more about actually how to contribute to the code, we need to provide development opportunities. And so, like I said, we have developers and we have scientists, and I think for them to work together very as well as possible, I think they all need to move to the middle a little bit. So I think it's important to have developers, maybe allow them to or give them the opportunity to run studies, but also for scientists to learn how to code. Hackathons, I think, are an important part in growing the community, and traineeships, I think, will be essential. And so again, a big shout out to Paul and Adam for launching this idea of Chiron. And I'm very excited about that, and certainly it has my full support. There might be other ideas, and I certainly don't have all the answers. So if anybody has an idea, please chime in and let us know. Another important point about growing the community is to make the economics work. So just briefly going back to 2007, Martijn, my main problem for working on open source software was I just had no financial backing for that. So we should make sure that the money flow, or whatever you want to call it, aligns with the work that needs to be done. I don't have a good idea of how exactly to do that, but certainly we should allow more institutions to lead and provide maintainers, because I think the money is there. We just should make it easier for institutions to actually jump in. So I know that Eden and now the Darwin project, they want to contribute, also the developers, and of course we have the RU Institute that wants to contribute. So there is goodwill and there is money. We just need to make sure that actually happens. We also should be very open to commercial partners. So we should have a healthy commercial ecosystem, I would think, based on the Odyssey tools. And maybe those two things can be facilitated by just being better at giving credit where credit is due. So if there are organizations that are contributing to Odyssey and the Odyssey tools, what can we do to make that visible so that they can actually claim their contribution? But also at an individual level, if individuals are contributing to an Odyssey tool, like how can we make sure that that is recognized, that they, I don't know, put it on their CV or something, that they did an important pull request to an Odyssey package. And again, I'm just making stuff up here as I go along. Anybody that has ideas that could contribute to this, I think that will be very welcome. And lastly, as we grow the community, we should make sure that we have a community structure in place. And so we currently don't have a code of conduct, and we don't have any bylaws. Those we probably should start thinking about drafting. And so I don't have any experience with that, so I very would welcome other people to help think about this. But also, as more people start working on this, and I know, Adam, this is one of the things that you're very interested in, is to clearly define the interfaces between the software components, so that if we have multiple components that work together, if we have the interface well defined, then we can basically decouple those components a little bit better so that teams can work on them more independently. All right, so I said growing the community, I think is a no-brainer. That's something we should do. But I also think that it's important to keep the science at the core. And so if we think about the science, as I explained previously, we have the methods research that is informing the analytics and how we implement them. And actually, it goes both ways, because the method research is actually using the analytics implementation. But one of the consequences of this is that because we're doing this research, it keeps on evolving the software requirements that we have. What we thought was a good idea yesterday might actually turn out to be a bad idea tomorrow. And certainly for developers, that might actually be pretty frustrating, that we don't seem to know what we're doing. But my response to that will be this quote from Albert Einstein: "If we knew what it was we were doing, it wouldn't be called research, would it?" So just to know, our insight will evolve, and therefore the software will need to change, and we actually need to build a bit of that flexibility into the software. On the flip side, if we're building software, we shouldn't just be building software for the sake of just having cool tools that look cool, although they need to look cool. But we should continue to demand science behind our software. Whenever we have a tool, we should be thinking very critically, how can we science the hell out of this? But it's also not just how the tools are developed. I think at the core, our tools should have the scientific principle embedded in them. And so what I mean by that is, so we have these analytics that turn data into evidence. And we do our methods research, and our methods research may show that under certain circumstances, these methods are good. But then in a specific circumstance where we actually apply the method, we then again need to assert that it's good. We need to continue to ask the question, hasn't nature misled us in this situation? And so I would argue the key feature in which Odyssey software distinguishes itself from other analytic software is that we continuously aim to generate these diagnostics that try to test our assumptions that we're making as we generate this evidence. And so my personal favorite, of course, is the negative control distribution. But we also now have the core diagnostics as an important tool, or just the covariate balance, and the list goes on. So all of these diagnostics are to make sure that nature hasn't misled us into thinking, into knowing we think something that's actually not true. And actually, if you think about how we develop software just in general, the whole notion of a unit test follows this framework as well. So just making sure that the analysis actually does what it's supposed to do, which is what we test through unit tests, I think is a very important part of this. Our software basically adhering to the scientific principles. And I'm very happy to say that we now have over 80% coverage for most of our Hades packages, thanks to the unit testathon that we had last year. A new development that we've been thinking about but haven't really done much with. So we have the user here at the end who's receiving both the evidence and the diagnostics that will tell her or him whether to trust the evidence. But we could also use our analytic tools as sort of a pipeline to forward the best practices that we learned from our methods research. And so ideas that have been, an idea that has been proposed is to maybe provide some decision support when people are using our tools. And just a specific example, our tools very much allow you to use to specify a non-user comparator, where we very often believe that that's actually not a good idea. And so just something that expresses that, well, the things that you're now trying to do might not be the best thing to do, even though the tools allow you to do it. I think that will be a good thing to help improve the science. All right, really getting very philosophical here. Another question that I also sometimes wonder about is, what can science learn from open source? So we've been talking about how open source basically our open source software needs to incorporate science, but is there a flip side to this? And I think there is, but I don't have a good idea of how. I just have the question here, because scientists still tend to work in silos or cliques. Like, I'm certainly guilty of that. I have my favorite collaborators that I always work with. A study is often kept secret until the paper is published. And luckily, Odyssey here is at the forefront of study transparency. So very quickly already you'll see a study appear in the Odyssey Studies organization. But still, we could do much better with this transparency. And so just thinking out loud, so if we're thinking about science, and if we could treat it the same way that we treat an open source software community, well, what would be the equivalent of an issue, a pull request, or a fork? And I just don't have any idea, but I'd like to think about this. And so if people would like to think with me on this question, please let me know. Really, I think we could reinvent how the scientific discussion takes place if we try to answer this question. Anyway, so as I'm closing the end of my talk, so just to get real with you, and so what really happened to 2007 Martijn? Well, like I already alluded to, the economics for 2007 Martijn changed. I got a new employer, started working for J&J, and that new employer actually allowed me to spend time on software maintenance. The old one, Erasmus MC, just by the nature of how academia works, my goal was to write papers and to write grants. And that was mainly like the thing that I had to do, and therefore didn't have a lot of time to support open source software. And so just that change in economics for me made it possible to work on open source. And I know that that's like a lot of people are still, who are on this call even, are in academia, and so I very much understand the predicament that they're in, and that they're not able to spend as much time on open source as I am. just by virtue of who's paying my salary. One other thing that happened in the 15 years in between is open science. So nowadays, sharing code and functional software is now just recognized as a necessary ingredient for science to progress. So that happened. But I think if you ask me, like what for me the most important driver is just observational research must do better. So we've seen now also through the OMOP experiment that the current status quo just I don't think is good enough. We can do a lot better, but the only way in which we can actually have adoption of these new methods that we're developing is if they're readily available. So for me, at least, that is the main driver for why I am now a firm believer in open source, and certainly the open source software that we develop in Odyssey. So just concluding thoughts, open source software is at the core of Odyssey science for obvious reasons, I would say, but only in hindsight obvious. I would say we have already been incredibly successful. But now we have to deliver on our promise. And I'm thinking very strongly here of Darwin, that we have to make sure that all of Odyssey, we can contribute to this great new endeavor. Our open source community has grown quite a bit. It needs to grow more, but it also needs to mature. Like I said, we don't even have a code of conduct and bylaws. And so I'm very grateful for I actually have that later on. So I'm excited about the future, but it will require a community. So I certainly can't do this on my own. I'm just a scientist who happened to stumble on open source software. And so I want to do a big shout out to the open source community work group, and especially Paul and Adam's leadership, because I think you've stepped up at exactly the right time to help us mature our open source community. And so my last thought is science. And with that, I'm at the end of it and end of my talk. Thanks so much for listening.